I'm going to be looking at the spatial analysis of extreme precipitation events, specifically within Michigan and Georgia, because eventually next semester we're going to want to incorporate the Gleason project that we just talked about, and I'll go into that a little bit further at the end. So an NBC News article reported that as of November 9, 2023, the United States has experienced 25 weather disasters worth $1 billion in damages. This information was first reported by the National Oceanic and Atmospheric Administration's monthly climate report, which detailed these events tallying more than any year since 1990. Extreme events including flooding in the northeastern U.S. and California especially, with flooding predicted to become more extreme, a need for collecting data and analyzing historical precipitation to predict future events is increasingly necessary. This project seeks to explain the spatial analysis of extreme weather events, particularly within Michigan and Georgia, as we start with precipitation events and then move on from there to get more spatial analysis. We start with an end goal of analyzing extreme precipitation events, and research so far has included initial cleaning of collected data sets with some basic trend analysis along with mapping. The states of Michigan and Georgia were chosen to connect to Gleason next semester. Our precipitation data analysis done here and in the future will be repeated for Detroit and coastal Georgia as focus areas for that project, seeking to understand regionally severe flooding related to infrastructure damage. Throughout this presentation, we will complete the following. We'll ascertain the Michigan and Georgia stations reporting the highest average annual, hourly, and daily precipitation events with the corresponding years they occurred since 1970. These factors will then be mapped to find initial spatial relationships. We will connect corresponding years of highest precipitation by hourly, daily, and average annual timeframes to a secondary data set on severe weather event types reported in those corresponding years. Notes in this data set will be informative of the spatial origination of large storms. As certain characteristics to relate the second data set to the first are missing or untrustworthy, other data collection types will be taken next semester to further the precipitation and storm type spatial analysis. We start by downloading precipitation data from the Cooperative Observer Program, or COOP, hourly precipitation data provided by NOAA. Volunteers in most U.S. states, there is one state that doesn't, I believe it was Rhode Island. In most U.S. states, collect precipitation gauge levels, denoting how much precipitation occurred in a given period of time. We take hourly and daily levels of precipitation and start by determining if a sufficient amount of stations exist to find precipitation spatial patterns within Georgia and Michigan. Because we don't want to do all this data analysis if we only have one or two stations reporting. We do not want to gain many stations either that provide data, but also lose a significant year range required to perform significant historical analysis. Based on figures 1 and 2, Georgia and Michigan have enough stations after 1970 to perform comprehensive precipitation gauge analysis. Now that we have a year range and enough stations, we create maps of average annual precipitation for Michigan and Georgia for figures 3 and 4. Keeping station numbers instead of location names attached to each data point helps ensure we are looking at the same stations when downloading and analyzing other NOAA datasets that may have multiple versions of one station in their analysis. For instance, this happens when stations record year gaps, leading to multiple versions of location-based datasets. Already we see Michigan experiences a greater range of average annual precipitation as compared to Georgia, anywhere from 5 to 35 inches. However, Georgia experiences anywhere from 36 to 48 inches, with a maximum value significantly higher by about 13 inches than Michigan is reporting. We consider the highest values as the top 10% or 90th percentile, as seen in figures 5 through 10. The top 10% were chosen as we want to work with a limited number of stations to compare to other data sets more easily. However, going any higher gives us merely one station to work with for most cases, and that's just not usable. By Figure 5, a station in Harbor Beach, Michigan recorded the greatest value of average annual precipitation, about 37 inches in 2001. This location is not included in the top 10% of maximum hourly and daily precipitation recorded in Figures 6 and 7. Those figures tell us Manistee, Michigan, recorded the highest value of hourly precipitation at 3.63 inches in 2010, and Vassar, Michigan recorded the highest value of daily precipitation at 7.2 inches in 1986. An interesting note is that Grayling, Michigan has both the second largest maximum hourly and second largest average annual precipitation value. All right, so now moving on to Georgia. The Dallas, Georgia station recorded the highest average annual precipitation for that state at about 49 inches in 1970. This location is included in the top 10% of maximum daily precipitation recorded for Georgia in Figure 10. However, this is decades apart. Dallas also recorded the highest daily precipitation amount at 9.2 inches in 2009. And Figure 9 tells us Jackson Dam, Georgia, recorded the highest value of hourly precipitation at 8.4 inches in 1971. Thus, we have some interconnections between locations and the top 10% of hourly, daily, and average annual precipitation recorded, especially as seen with Dallas, Georgia. There are also patterns in the date columns that I can't note. Georgia's highest hourly precipitation values were recorded in the 1970s. Two of Michigan's greatest hourly precipitation values were recorded in the 1990s, and two in the 2000s were only a few years in difference. Two of Michigan's highest daily precipitation values were recorded 1 year apart between 1979 and 1980. We now create maps of max hourly and daily precipitation to see if we miss location similarities in relation to our average annual precipitation maps. North Central and Southeast Michigan, along with one spot in the peninsula, which is that yellow dot on the right-hand side from your perspective, along with one part of the Southwest, appear to experience the greatest hourly precipitation values. One area of southwestern Michigan especially has the highest daily precipitation recorded. Comparing the maps for Georgia now, Georgia is much more clear as its highest values of daily and average annual precipitation occurred at the same station. Also, its greatest hourly precipitation value occurred in the next town over. Georgia's maximum hourly values exhibit much less variability than compared to Michigan. We see a few areas of high daily values from north central Georgia to its northwest tip. One could also argue that the southeast and east areas experience greater daily precipitation, as those darker data points still reach about 7 or more inches of precipitation. Seeking a new data set to gain deeper understanding of the years that record greatest hourly, daily, and average annual precipitation allows for the examination of extreme weather events also occurring in those years, such as hail, which is directly related to high precipitation. This lets us compare two sources of weather records to start examining extreme weather spatial parallels besides precipitation. A storm events database provided by NOAA, the National Center for Environmental Information, and the National Weather Service contains weather events from January 1950 to August 2023. Changes in the processing and collection of data gives different year ranges for some event types. Tornadoes, thunderstorm winds, and hail have been reported from 1955 to 1992. All weather events were reported on after 1996. We also note that data tables produced include townships within counties. So instead of looking at Dallas, Georgia, for example, we're looking at the entire county that makes up that township. Because obviously the townships are too small to always report on. It should also be stated that only sections of tables that I collected will be shown on slides just for readability. They get pretty lengthy. And then as we initially announced the greatest numerical values given, we easily see the most important aspect of this data set is actually the observer note-keeping that was taken. Although reported damage values are relatively low, we should also remember that we are looking at smaller areas of counties. not larger cities such as Chicago or New York. So any amount of damage is relatively significant. Okay, so we start by examining 2010 when Manistee recorded the highest hourly precipitation value, which resides within Schoolcraft County, and we adjust our year range accordingly to 2010. Figure 16 shows 4 instances of winter weather, 2 of thunderstorm winds, 2 of high winds, and 4 cases of hail. Event notes describe amounts and types of precipitation at observer stations. Episode notes state spatial movements of these events. In cases of winter weather, 4.5 to 6 inches of lake effect snow was reported in the portions of the county with reduced visibility. Manistee was reported to have 9 inches of snow over a 12-hour period in one instance with heavy north winds. During this event, a storm system moved from the Central Plains into the Great Lakes, dumped heavy snow over portions of west and central upper Michigan over the course of 2 days. In many cases of hail and thunderstorm or high winds, low-pressure systems originated in the plains or brought cold fronts east across South Ontario. 2 stays of hail greater than 1 inch included damaging thunderstorms. For 2 times of high winds, there was experienced trees down and power lines down. And surprisingly, the lower magnitude of high winds caused the only damage reported in this year, which was $2,000 in property damage. We now move on to 1986 when Vassar, Michigan, within Tuscola County, recorded the greatest daily precipitation value. Tuscola County only experienced 1 major weather event that year, including an inch of hail. We can at least partially attribute a lack of events this year to the minimum amount of data collection available prior to 1992, as previously stated. Harbor Beach, Michigan, had the highest average annual precipitation in 2001 within Huron County. We have significantly less magnitudes given than in Schoolcraft County. Damages were more significant, totaling $11,500 in property damage. The tornado was directly related to Harbor Beach, as the narrative reports a shower over the warm waters of Lake Huron, producing a waterspout that traveled on shore through its harbor. This county saw 4 inches of snow in 3 hours, among other weather events. Another time, several streets flooded, leading to $4,000 in property damage, accounting for half of the monetary damage reported. Numerous Huron County 2021 weather events, as compared to the previous counties, are a direct indicator of why this area has the highest average annual precipitation. This includes heavy snow of greatest frequency as seen in Figure 19, and weather events stem from low pressures in the plains pushing a warm front over the Ohio Valley. We now transition to Georgia in 1970 when Dallas and Paulding County had the highest average annual precipitation historically for that state. Paulding recorded no severe weather events for this year, which is actually unsurprising, as again it tracks back to the lack of information reported before in 1992, which we are starting to see as an issue. A similar problem already happened with Vassar, Michigan and Tuscola County, as I just discussed. We again see this problem with Jasper County, where Jackson Dam reported the highest hourly precipitation value. Again, we see that lack of information in Figure 20. We proceed to 2009 when Dallas similarly recorded the highest daily precipitation for Georgia. Even though Huron County had 1 flood incident, Dallas kind of pales in comparison to this in terms of floods. 5 instances of hail, 2 of flash flooding, and 2 of flooding occurred according to Figure 21. A total of $10.8 million in damages were recorded for this year. A strong low jet pushed warm, moist Gulf air into this region, which caused several major thunderstorms and tornadoes. All right, so with this new information, we have thus started correlating the spatial movement of large storms to the counties that experience the greatest precipitation with differing time frames or averaging through the utilization of this observer notes. Further tracking of spatial connections between our townships. Sorry, guys. Okay. Further tracking of spatial connections between our townships or counties of high precipitation in conjunction with weather forecasting can be achieved by implementing satellite imagery. As an example, several notes include mentions of cold fronts and low pressure systems from the plains as a causality of observed severe weather. Temperature and precipitation layer files are two examples of factors spatially gauged with satellite imagery. This can provide clear indicators of event severity than given in previously utilized National Weather Service dataset notes. We also have more reliable intensity magnitudes and just more given in general, and spatial patterns instead of varying observer expertise and merely originalization of spatial events. By this method, spatial analysis can be more readily exacted to smaller locations. Once again, maps are colorized with factors such as temperature and precipitation, and we can select that data and extract our own data sets with ArcGIS Pro software. Satellite photos can also be used when looking at severe weather events in corresponding years of high average annual, hourly, and daily values. We can also answer questions through these methods, such as whether the county with highest average annual precipitation, Dallas, Georgia, had similar storm patterns to when it reported highest daily precipitation decades earlier. We could also visualize precipitation on days of high flooding events according to our second data set in Huron County. I mentioned we will be incorporating Detroit and coastal Georgia to connect with the LISA project. To reiterate, this will involve the repetition of the previous analysis for these regions. This will also include the remote sensing or satellite imagery and data extrapolation process discussed previously. In addition to that, streamflow data can be provided for specific information on types of severe weather events we are concerned about for this project, more specifically flooding from streamflow data. Thus, we have more quantitative and observable approaches to fill in previous magnitude or observer reliability gaps as seen in the previous data sets, and further explore the spatial analysis of severe weather events, tracing back to our first precipitation data set. Going forward, next semester, we will hopefully be in conjunction with the LISA project. Here are references. That's it.